This video is all about integration by substitution. It's quite a complicated and quite a long process, so I'm going to use an analogy to try and explain each stage. Then we'll look at a couple of examples at the end. So I'm first just going to be focused on the process of what we're doing and why. So the analogy is, I want you to imagine yourself on a hostile, barren planet where there's volcanoes and no water, there's no oxygen, there's no food. It's incredibly difficult, well, impossible to survive, and integration is really difficult. This is the X world. We don't want to be there. We want to be on the U world, where water is plentiful, we have food, we have oxygen, we have nice fluffy clouds, and rabbits are jumping in the fields, and everything is happy, and integration is really easy. So, how do we get from the X world to the U world? Well, we do it with a rocket, of course. And so our rocket is going to take us from the X world to the U world. What is the rocket in terms of my maths? Well, it will be some sort of relationship between X and U. It might be that I'm saying that X is going to be, I don't know, 2U plus 1. Or it could be X is 3 times U, or it might be X is equal to sine U. Or we could do it the other way around. We could say that U is equal to e to the power X, or U equals 3x minus 7, or I don't know, it depends on the situation. It depends on what this equation is. But our rocket will be some sort of relationship between X and U. Once we've decided on our rocket, once we've decided on the equation, how do we then start the rocket? Well, we need a key. So how do we find our key? What we do is we differentiate our equation. So if our equation is u as some function of x, if I differentiate that, I'll get du by dx is equal to something. I am then going to rearrange that to make the dx the subject. So I'm going to move the dx up to the top over there, and whatever I had when I differentiated, I'll move that to the bottom. So I'd get du over something is equal to dx. This is my key. That's the key that's going to start the spaceship. So I have the key in my hand. What do I then need to do? Well, I need to put that key into the ignition. So I'm taking my key here, my du divided by whatever I got when I differentiated, and I'm going to substitute it in to the ignition here. I'm replacing the dx with du divided by whatever. What's going to happen then is my integral will become f of x, and the du will become, the dx will become du over something. And at this stage, what you will notice is there'll be some sort of simplification. There'll be some cancellation or some identity or something that's going to simplify this integral. All we will then need to do is make sure that we are completely in the u world, so any x's will get changed back into u using this identity. And then we will be in the u world where everything is nice and easy. So just to repeat the process of what we do, and then we'll look at some examples and hopefully it'll be a bit clearer. We take our rocket, we differentiate it to find the key. So we differentiate and then we make dx the subject. We then substitute our key into the ignition. We get some simplification, and we change everything to be in terms of u, where it is easy. Let's see a couple of examples. So this question says to use the substitution u equals x squared plus 1 to find the integral of 2x times x squared plus 1 all cubed with respect to x. So this is our spaceship. We are going to differentiate that to get our key. So du, I'm differentiating u with respect to x. When I differentiate x squared, I'll get to 2x, and when I differentiate the 1, it'll be 0. I am now going to rearrange to make the dx the subject. So I'm going to move the dx to the top here, and I'll move the 2x to the bottom down there. So I'll get du over 2x is equal to dx. This is my key that I am now going to put into the ignition. So I will still have the 2x's there for now, as is the x squared plus 1 all cubed, but the dx has become du over 2x. Now I'm looking for some sort of simplification. I can see that I've got a 2x here, and I've got a 2x there. They're going to cancel out. And so I will just then be left with, well, I've got the x squared plus 1 here, and I know that is u. X squared plus 1 in the u world is just simply u. Oops. So I'm going to replace the x squared plus 1 with u cubed du. And that's it. That's left. That's all that's left over from that complicated integral, because the key simplified this massively. The 2x's cancelled out completely and just left me with u cubed, which is really easy to do now. This integral in the u world is so easy. All I need to do is add 1 to the power, divide by the new power, plus c. Now, that's the answer in the u world. I do want to give my answer in the x world, however, because that's the world that the question was set in. So I'm now going to replace that u back. I'm going to jump back in my spaceship, the u equals x squared plus 1, and I'm going to swap that u for the x squared plus 1, and that is my final answer. If you wanted to check this, remember, we can check our answers, because if I differentiate this, I should get back to that original equation, the original integral. So let's check this quickly. Let's differentiate this. So first of all, let's differentiate the outside function. So I'm going to times by 4. And take 1 away from the power. Then by the chain rule, I'd have to multiply by the derivative of the inside, which is 2x. We can see that the 4 times a quarter, that's just going to be 1. And hopefully you can see here that this is the same thing as what I started with. So that's correct. Let's do another example. Okay, we've got the integral of sine x cos x multiplied by 1 plus sine x cubed. Notice in this case they have not told me what substitution to use. Now, in your exam, 99% of the time they will tell you what substitution to use. So don't worry too much about it if you're not seeing this straight away. If you do need to come up with your own substitution, don't panic. Just look at this and think, well, what's really complicated about this? There's quite a few complicated things about it, but I would say the most complicated thing is the fact that we have to cube this awkward thing. It would be much easier if it was just x cubed by itself, or u cubed by itself. So the most complicated thing about this integral, I think, is the fact that we've got a 1 plus sine x inside that bracket. So based on that, I think the substitution will be u equals 1 plus sine x. I think that's a sensible place to start, because that would then make this just become a u cubed. So that's my spaceship. Let's now get our key. So let's differentiate that. So du by dx, the 1 would just disappear. The sine x would differentiate to be cos x. Let's make dx the subject. So let's move that to the top there and move the cos x to the bottom. So I've got du over cos x is equal to dx. This is my key. I am now going to put the key into the ignition. So I would have sine x cos x 1 plus sine x cubed multiplied by the du over cos x. Now, I notice that there is going to be some simplification, because dividing by the cos x here is going to cancel this cos x out completely. So they're going to be gone. So I don't have to worry about that. All I now need to worry about is the sine x, the brackets. Now the sine x at the front there, what's that in terms of the u world? Well, this is my spaceship. This is how I get from the x world to the u world. So let's look at that. U is equal to 1 plus sine x. If I were to subtract 1 from both sides there, then I would see that sine x is just the same thing as u minus 1 in the u world. So I can replace that sine x with u minus 1. Next, I've got the 1 plus sine x there. What's that in terms of the u world? Well, I know that's just going to be u. So that is going to become u cubed with the du on the end. Now I have a much simpler integral to do. Clearly in the u world, that is easier than all of that in the x world. So let's do that integral. In order to integrate this, I'm going to expand the brackets. So u times u cubed is u to the power 4. Minus 1 times u cubed is minus u cubed. Now I will add 1 to the power and divide by the new power. Add 1 to the power and divide by the new power, plus c. And now finally, to get my final answer, I will substitute my 1 plus sine x back instead of the u. And there we go. This is my final answer. And there we go. That is integration by substitution. Key things to remember then is the first thing you do is you take your substitution and you differentiate it. You then rearrange to make dx the subject, so you've got your key, and you substitute your key into the ignition so that you have simplification. That's the key, that's the most important thing when you're doing integration by substitution.